Greetings, 6th grade parents and students. Mr. Korn here. This lesson is going to be about ratios, but this is a website called brainingcamp.com. This is a website that I use for 6th grade. It goes through a lot of interactive visual lessons, and we use this for lessons, practice questions, and this is a good resource for students because this is helpful for if they are stuck or forget something we learned in class. They all actually have logins for this website that they made. So if you do have a computer at home and access to the internet, students can actually log on to this website for lessons, extra practice questions, and word problems. So the lesson we learned today in our new 6th grade topic is ratios. So the way to use this website, and I should have showed you this before I went clicking around, is that if you go to lessons up here, okay, there's a variety of lessons. Most of these lessons are at a 5th or 6th grade level. Okay, this website kind of mixes both levels. But there's many good 5th grade review topics and also 6th grade topics. And the one lesson we're going to, if you scroll down a bit, is ratios. Each lesson that you click on has a lesson, a manipulative, which is a little model you can play around with, some practice questions based on the lesson, some word problems, and a challenge section. Okay, but right now we're going to focus for this video on the lesson. Okay, this lesson's about ratios. Okay, you can hit next down at the bottom right corner to move the slides back and forth. And in the bottom left corner is the back button if you need to go back a slide. And in the bottom right shows you what slide we're on. So I'm actually going to start on slide 5. And we're learning about ratios. And what this says is that ratio is a comparison of two numbers or quantities. Okay? In this picture we have 2 circles, we have 3 triangles, and if you count them all, we have 1, 2, 3, 4, 5 total shapes. Using what we call ratios, we can compare, we can make comparisons of things that we see. Okay? The comparison we see here is that there are 2 circles to 3 triangles. So for every 2 circles we have 3 triangles. And for every 3 triangles we have 2 circles, because that is our ratio of circles to triangles in this picture. Okay? Let's keep going. Ratios, as we learned today, can be written 3 different ways. So if we're writing the ratio of circles to triangles, it's very important that your student reads the question to see which number to put first when they're making their ratio. This question says circles first to triangles and triangles second. So when we make our ratio, we put the number of circles first, which is 2, and the number of triangles second, which is 3. So the ratio of circles to triangles, again, can be written 3 ways. We can compare our quantities with the word 2. 2 to 3. We can also use a colon and say that the ratio of circles to triangles is 2 to 3, except for we're using a colon to separate the 2 numbers. We can also write our ratio as a fraction. 2 fraction bar 3. And a better way of writing that would be to make your fraction up and down like a normal fraction, whereas the circles, which is the first number in our ratio, is the numerator, and 3 would be the denominator. So all of these are different ways of writing the ratio of circles to triangles. Let's move on. So here's a practice for the students, and it asks the ratio of squares to stars. What is the ratio of squares to stars? Well, we have to look. In our question, the squares, it asks for the squares first, then the stars. So we can say that our ratio is 1 for the squares to 4 stars. We have a ratio of 1 to 4. So we can say that the ratio of squares to stars is 1 to 4. And again, you can say that 3 different ways. with the word 2, with a colon like it is here, or you can put it as a fraction 1 over 4. Now, the order is important for ratios, as I mentioned before. If the question asks for the ratio of squares to stars, and it lists squares first, then stars second, take the number of squares and write that first in your ratio. Then write your colon, and then stars, which happens to be 4 in this case. However, if the question asked for the ratio of stars to squares, and it said stars first in the question, then squares, doesn't matter which order the picture comes in. If the question asks stars first to squares, put the number of stars first, which is 4, then the number of squares, which is 1. Okay, so you got to look at the question, and the order matters. Squares to stars or stars to squares. Okay. The last thing that's going to be talked about in this video is there's 2 types of ratios. Okay. As you'll see in this picture, there's 1 square, there's 4 stars, but altogether there's 5 total shapes. 1 square plus 4 stars is 5 shapes. So sometimes it'll ask for the ratio of squares to stars. This is called a part-to-part ratio. In a part-to-part ratio, we compare 2 separate parts. We compare squares to stars. So it's a comparison of 2 parts. However, there's another type of ratio. And the other type of ratio is called a part-to-whole ratio, such as squares to total number of shapes. In a part-to-whole ratio, we compare a part, the squares, to all the shapes on the board. There's 5 shapes on the board, 1 square plus 4 stars. So a part-to-whole ratio we can make is, what is the ratio of squares to shapes, all the shapes you see in the picture? Well, that would be squares to shapes 1 to 5. Whereas this one was a part to a part. What part were squares as opposed to which part were stars? Whereas this part-to-whole ratio compared which part of the picture were squares compared to which part were to all the shapes that we had. Okay? And then a simple practice on which one of these are part-to-part and part-to-whole ratios. Here we see a set of animals. We have a reptile, a bird, a mammal, another mammal, and another bird. But altogether we have 1, 2, 3, 4, 5 animals. So if we say the ratio of 2 birds to 1 reptile, there are 2 birds in the picture, to 1 reptile, birds to reptiles, we can say this is a part-to-part. We're comparing the part that's birds to the part that's reptiles. As opposed to this ratio, which is 2 birds to 5 animals. In this ratio, we're comparing the part that's birds to all the animals in the picture, which there are 5. 2, 3, 4, 5. So this would be a part-to-whole ratio, because we're comparing a part, the birds, to the whole thing. This next ratio, 2 mammals to 2 birds, would be a part-to-part. We're comparing the part that's mammals, 2, to the part that's birds, also 2. That ratio is 2 to 2. There are 2 mammals for every 2 birds in this picture. And then lastly, they have a comparison of total animals to reptiles. This is also part-to-whole. Even though they put the whole first, we're comparing the whole set of animals in our picture, which is 5, to the part of it that's a reptile, 1. Okay? And what's good about Brain & Camp is that if you look at the top, you can go to manipulative, which is a model, Okay? So students can play around with this. Okay, change the ratio of squares to circles. Okay? And write it out either as a colon, a fraction, or words. Okay? As you'll see in this ratio, I have 4 squares to 5 circles, 4 to 5. That's written with words, with a colon, and as a fraction. Okay? This is, of course, squares to circles, a part-to-part ratio. But I could change it to make it squares to all and make a part-to-whole ratio. Squares to total shapes. There are 4 squares to 9 total shapes. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, I can write this with words. I can write this part-to-whole ratio with a colon or as a fraction. There's also questions that the students can practice answering, such as what is the ratio of squares to stars? So since squares comes first in the question, we want to put the number of squares first. There are 6 squares. Then, what is the number of stars? Squares to stars. There are 9 stars. This is a part-to-part ratio of squares to stars, so we could say our ratio is A, 6 to 9. Alright? If you have any questions, let me know. Signing off. Have a great night.